Well, hey guys, this is Mr. Turboville, and I'm going to talk to you about Module 12.2. Trying to get some things set up here. And 12.2, let's back up just a little bit. Let's go back to our notes. So we got this form here, and we talked about the idea between sequences and series, okay? And then we said in 12.1 we talked about arithmetic patterns, okay? We did the explicit formula for arithmetic patterns, looking for the common difference, and this is how we would do that right here. This is the common difference by subtracting. But as we move into module 12.2 and 3, these are going to be talking about geometric patterns, which is a division. So you take the second divided by the previous, third divided by the previous, and that pattern should keep on going. And these should be the same if it's going to be geometric. And in Algebra 2, we start off with this arithmetic stuff, but really our focus in Algebra 2 is geometric, okay? As opposed to the linear patterns of arithmetic patterns. So that's kind of where we're at now. We're moving into these multiplication division patterns, and this is how we find R. Just a quick reminder of how that works. So now as I go into the textbook, and we go over here to this first section here, and you always want to know what page that is. I'm in the teacher's book, but it's page 597 here. And they open up this idea with something called a fractal tree. So what this works out is that you got this length of this tree here, and then you take half of that and so it's like you make a copy of this and break it up into two, and then make a copy of one of those and break it up into two, and you keep on going half and half and half and half and half. And it's kind of interesting, but it's taking that half pattern that they're wanting to show you. And just for grins and giggles, I thought I'd show you a couple of videos that deal with these fractals that you could look up and spend more time with, but I'm just going to show you a couple of them. Okay. So one thing you've seen I've done is something called a Sierpinski's triangle, and we got one here, a guy who has hand drawn it, and do a quick little preview of it. And you can see how it starts with these little triangles, and then you build another a triangle half the size, and then another triangle half the size, another triangle half the size, and you keep on getting half and half and half and half and half and half. Okay, because that's a geometric pattern, because you're doing it by half, dividing by 2. And you keep on going, and that's interesting enough. Okay, so let's just kind of set you up. But if you keep on going, and they did this kind of digital concept, they said, hey, what would that look like? And so you keep on going deeper and deeper and deeper into this, and it continually is going into half and half and half. And so this is idea of a geometric pattern. This one's kind of cool too. And a fractal is just a similar kind of patterns. And so you see this pattern here, then it comes up right there again. And then they're going to go, see this guy here, keep on zooming in. I mean, they're zooming in hundreds of thousands of times. And then they're going to pick another little spot, and yep, there they are again. And it's kind of like a boat coming up there, doesn't it? It's funny. But and all these different self-similar patterns, and so all this is coming up with the geometric patterns. And they've colorized it to make it interesting. But just show you a little bit of where geometric sequences and patterns could go to, and that just kind of makes it a little bit more interesting to think about. But we're starting off at the basics, but that's some more advanced work that it could go to. Some interesting enough. But so that's just kind of bonus. But here we are. Geometric sequences is where we're at in 12.2. And they start off with that little fractals. We took a little side trip there. And they go through those process right there. And I want to remind you, we talked about this. A geometric pattern is this exponential growth thing going on. And we're just doing the dots themselves. We're not connecting the dots, okay, in this case, because we're just one step, then the next step, and then the next step, okay. And then that would be an exponential decay kind of situation. Alright, so here we are on page 600 even, okay, and we're getting to the terms. So I'm going to go over to the student book at this point. Okay, and they remind us it's a geometric sequence, and we're talking about the explicit rule. Okay, and so here is what they have for the explicit rule here, and they use f of n instead of a sub n. Okay, remember that. And it just means where they start, and then the ratio, which is what we talked about before, that r, and then n minus 1. Well, what if they start at 0? Well, that's when you just drop the 1 right there. So it's going to be one of these two guys right here. So that one if you start at 0, and this one when you start at 1. Okay, so those are the two guys here. Just a quick refresher, when we're talking about recursive patterns, okay, that little guy right there is always going to be the ratio. And what did we say this was? We said that this was, when you see this guy here, you're going to think, we'll see if this will be too much. We said this is going to be previous term. So when you see that n minus 1, that's previous term. That may be a little thick. Okay? That's what that n minus 1 should make you think of. And they always got to tell you whether you're going to be starting at 0 or starting at 1 for those patterns. So all that's the same as it was with arithmetic patterns, but now we're going to be doing multiplication patterns instead. So here we go. Here's our first little guy here, and here's our chart. So I'm going to kind of just put a big box here so we're not worried about what they got to say. I'm going to do my own thing here. So how would we get this guy started? Well, first thing is that remember that that this right here means that's a sub 0. 6 is what? A sub 1. 12 is a sub 2. Just kind of quick refresher. So how is this? This one's going to start at 0, isn't it? So let's come over to the side and just make a note that a sub 0 equals 3. Okay. So, but what is our r? What is the r? What is r? Well, r is going to be 6 divided by 3, which is 2. But let's double check and make sure this pattern stays true. Let's see if, see what 12 divided by 6. Is that also 2? Yeah. So we do have a common ratio, because these are the same. So there's our r, okay? So there's r. And so we always need, where do you start and what's the pattern? Okay? So what's next? Well, we're going to write our formula. So our formula, our model, our rule, say so it's going to be, so we got a sub n equals a r to the n minus 1. Whoops, but we're not starting at 1, are we? So we could say this is the n minus 0, but there's no point in putting a 0. Okay, so we can come down here and we got a sub n equals our starting point, our radius, and then the n in this case. So let's put again what we know. So our a sub 0 is 3, our r is 2, and since we're not looking for any particular point, we're going to go ahead and leave this an n. Okay, so this is a nth term rule, okay, because we're leaving the n in it. We wanted to know a model for the third term. Well, we would put a 3 here. Okay, so this is the explicit rule for this geometric sequence. Okay, so it don't look like sequences, doesn't have commas. Well, do you want me to make that happen for you? We can do that real quick. just come over here. Okay, this is 3, comma 6, comma 12, comma 24, comma dot dot dot. Makes it infinite, doesn't it? Easy enough. So that's how you would set up using a table. Okay. So looking at this guy here. Ooh, this one starts at 1. So this is a little different. So again, I'm not going to look at what they got going on here necessarily. We're going to start scratch for ourselves with this whole pattern again. Okay. So we note, what are we noting here? They start at 1, don't they? Okay. So that means A sub 1 equals 1 over 25. Excuse me. Okay, so there's our starting point, but now we need our common ratio. So let's check what that is. Oh my goodness. If I wanted to do common ratio, that means I would have to do 1/5 divided 1/25. Oh, goodness gracious. Well, we don't have to do that. We can pick any two we want to. Just got to make sure you do this one, the number divided by the previous number. So we could say 5 divided by 1. Well, that equals 5. Okay, what about 25 divided by 5? Still 5. So we have a common ratio, right? Here is a common ratio. So this is definitely our R value. So we got our starting place, we got our pattern. Okay, so let's write our formula. So what does that formula look like again? Okay, this is A sub n equals A R to the n minus 1. That's what the geometric sequence formula looks like. Okay. So I'm going to rewrite this guy again. And this time I'm going to put some blanks or some boxes. Okay. Okay. So let me start putting some stuff in. So what is our A? Well, that's a 1 over 25. What is the R? 5. Now, if I wanted the 5th term, I would put A sub 5 here, and I would put a 5 there. But since I'm looking for the nth term, I need to leave this an n right here. And we still got 1. Why do we have the 1? Why do we have 1? Well, we got the minus 1 because we started with 1, remember? Right there. So that's why we got our minus 1. So let me clean it up, just make it look a little nicer, how you would normally write this kind of thing. Okay? So A sub n equals 1 over 25. And then you'd have, and I'm going to go ahead and leave it in parentheses so we can keep that track in our head what's going on here. 5 to the n minus 1. And that's how I would put it in my calculator if I was needing to put it in the calculator. So this is what we're looking for. What in the world did I just do? There we go. So I meant to put this highlighter going on here and say, hey, this is our answer. So there's a couple of good examples to get us started with. Okay. Alright, so let's slide on down here. That's a good one there. That's another good one here. Let's try this one as well. Let's try this one as well. Sometimes it throws people off. Okay, so what do we need to know first? Where's this thing starting? Well, it's starting right here, isn't it? With 1. So let's make note of some things. And this is how I want you to see your work done, okay? Let's see, we want to say it's A sub 1 equals 0.001. How else could you write that? Well, this is tenths, hundredths, thousandths. So this is 1 over 1,000. Just another thought. Okay, now what is the R value? Okay, well we could do 0.01 divided by 0.001, that's okay. We could do that. But we can also do 10 divided by 1 equals 10. And then we could come over here and take the 6 and divide it by the fifth term and say this is also 100 divided by 10, which is still 10. Okay, we got ourselves a common ratio here. So this is definitely what our R value is. So we got a beginning point and we got a ratio. So, and we know that it starts at 1. So I'm going to write my formula, my explicit formula. So A sub n equals A times R to the n minus 1. So A sub n equals you over there, you don't need there. Okay. So A, well that is 0.001, or I can say this is 1 over 1,000. Either one works fine. Okay. And then what's the R value? That's a 10. And again, what goes here? Well, since I'm wanting the generic, I'm going to leave the n in place. If I wanted the 8th term or the 20th term, then I would put that number right there. Okay, so I'm going to put an n in here. Now, how do I know for sure I got this right? Well, if I plug in a 4 for n, and I put this in my calculator, I better get a 1 on the other side. Okay, I better get a 1 on the other side. So let's think though, what is 4 minus 1? That's 3. 10 to the third power? Well, that's 1,000. Well, 1 over 1,000 times 1,000, well, that's going to equal 1,000 over 1,000, which is 1. So that turns out just fine. So that's how we can check our answers, is take your equation, plug in a number that you know what the answer is, and if you get that answer you're expecting, then you can say, hey, I'm doing pretty good here. So that's my explicit formula. Alright, I know you're ready to get jumping into the actual problems here. Okay. Well, what's up with this guy here though? So we got just a couple more things to go here. Well, when it comes to graphing, what do we say? Well, we're going to do 0, 2. Okay, so here's 0, 2, 0, 2. 1, 4, over 1, up 4. 2, 8, 2, 8. Well, there's more points on my chart, but that's all I'm going to fit on my diagram here, okay? On what they have given me. So that's the best I can do for the moment, okay? And so that's graphing as best I know how. And so just using these ordered pairs, okay, to work this through, okay? And again, if I did not have this chart, I could take this equation, okay? I would just simply say, alright, let's plug in a 0. Well, 2 to the 0 is 1, because anything to the 0 power is 1. So 1 times 2 is 2. Alright. Plug in a 1. 2 to the 1 is just 2, so 2 times 2 is 4. Plug in a 2, so 2 squared is 4, times 2 is 8. So I could create, that's how this table is created. Or I could plug this part right here into y equals, and it would give me this table as well. Okay, so those are different ideas as far as that's concerned on the graphing. And what happens if you have recursive rule though? What happens if you have the recursive rule? And I promise this will be my we'll call this good enough for the example. Okay, we'll do this last example and then we'll jump into the practice problems of your homework. Trying to see how long we've been going here. Huh. That's longer than I expected, but okay. And let's see, real quickly here. So what do we say? This is 0, 16. So 16 goes here. Okay. So this says 0.5 times the previous term. Well, what is the previous term? 16. Well, what's half of 16? 8. Okay, let's try again. 0.5 times the previous term. Well, what is the previous term? 8. Well, what's half of 8? 4. Okay, so this is 0.5 times the previous term. So what's half of 4? 2. All right, we're going to try 4 now. Okay, and now, so 4, our fourth term. So we're going to take, to get the fourth term, you're going to go back to the previous term and take it times 0.5, which is half, which is 1. How about the fifth term? Well, to get the fifth term, you're going to go back to the previous term and do 0.5, which is going to be 1/2 here, or 0.5. And you would continue that process out. You get your 6, and then that would end up being 1/4, or 0.25. And then you would graph these over here the best you can. And so that's how that process would work. So here is the R. And remember, this is previous term. Now, and this says n greater than 1, so you start at 0, pick up at 1, and keep going. Now, if it says from 1 to 4, that means you stop at 4, is all. Okay, so let's jump on into the practice problems at this point. I promise, here we go. So we're going to start on number 4, okay, on page 606, number 4. Okay. So I told, whoops, that's not what we needed there. Get this down a little bit. Here we go. It says write the explicit rule and the recursive rule. So we're just going to write the explicit rule. Okay, again, what do we need? We got a sub 0 equals 0.1. Okay, and what is R? Well, can't really get around my decimals here, so that's okay. I'll do 0.3 divided by 0.1. Well, that's just 3. So I need to double check those. So let's do 0.9 divided by 0.3. Well, that's still 3. So we got a nice common ratio running here. Okay, so that's our R. And let's plug it into our explicit formula. So, all right. So it starts at 0, so we're going to use a sub n equals a times r to the n minus 0. Okay, so, but we really don't need the minus 0, but I'm putting it in here to remind us that that's reason why, because that's a 0. Alright, so let's plug in what we know. So we got a sub n equals, that's going to be just plain n. And so we put 0.1 here, put a 3 there, turn on my highlighter, circle it, and say yippee-ki-yay, here we go. We're on ready for the next one. Okay. And we're doing 4 through 13 and then number 17. Okay, so here we go. So here's our starting point. So we got a sub 0 equals 100. Okay, our R value, well, that's 110 divided by 100. Also known as 1 over 10, and some of y'all might call that 0.1. I would say 1 over 10 is your best choice. And then here we go. So let's try the next couple. So 1 divided by 10. Oops, there we go. So this would be your R value. Okay. Here we go. Let's write our explicit formula. So it's A sub n equals A times R to the n minus, yes, 0. Again, you don't have to put the 0, but I keep on reinforcing that this is starting at 0. If it starts at 1, you put a 1. Okay, so we got A sub n. It's keeping it generic. If we wanted to know the fourth term, we would put a 4 in for n. Just leave that n right there. Okay, so what goes here for our first term? Looks like 100. Our ratio is 1 over 10. So if you plug this in with parentheses just like that into y equals, you better start getting this table. If not, we did something wrong. Okay, keeping on rolling. Okay, it looks like we got one that actually starts at 1. Okay, so here we are. So we're going to start with this guys right here. So A sub 1 equals 1,000. Okay, our value, that'd be 100 divided by 1,000. Okay, zeros cancel. Uh-oh, we got 1 over 10 again. And then we got 10 divided by 100 for our next group, and that's still 1 over 10. So turns out our R value for this one is still 1 over 10. But this time we're starting at 1. Okay, so our formula is A sub n equals A R to the n minus 1 this time. Okay, 1, because this is a 1. Okay. And if you rewrite the formula every time like I'm doing it, you will memorize this formula and get really good at it. Okay, what goes there? Ooh, 1,000. You're going to have to try to squeeze that in. And then 1 over 10. If you put that into your y equals, should give you this right here. Okay. Okay. People always ask about number 7. I don't know what their problem is. It's just like number 6. Okay. So where are we starting? At 1. Okay. So A sub 1 equals 10 to the 50th power. I don't care if it's 50th power. It's still whatever's there goes there. Okay. R. Well, that's going to be 10 to the 47th divided by 10 to the 50th. Oh goodness. Well, what is that? 47 minus 50 would give me 10 to the negative 3. Oh, we don't leave that way, do we? We got to change that over to 1 over 10 to the 3rd power. Now, does that stay true for our next set? Does our next set work that way? Well, let's see. 10 to the 44 divided by 10 to the 47th. Okay, again, that's 10 to the negative 3, which is 1 over 10 to the positive 3. So it turns out we do have a common ratio right there. So A sub n equals A times R to the n minus what? 1. Okay. So I'm not going to finish this one out. I'm just going to set you up. And you got to put in those guys. Okay? Alright. What's on next for the docket? Well, reversing this out a little bit, aren't we? Okay. So what happens when I plug in a 0 here was 4 to the 0 is 1. And so 1 times 1/2. Well, let me scoot this over so we can get that over there too. So that would be 1/2. Alright. So plug in a 1. Okay, that's so 4 to the 1st. What's half of 4? 2. Okay. Now plug in a 2. What's 4 squared? 16. What's half of 16? 8. 4 times 4 is 16. Half of 16 would be 8. Okay. So our starting place is 100. Is 1 half, and what's our rate? 4. So 4 halves make 2. 2 times 4 is 8. So I bet you this one's better be 16, right? This better be 16. So let's try. 4 to the 3rd power. That's 64. What's half of 6? Ooh, hold on a second. 4 times 4 is 16. What's 4 times 16? Let's double check that. Got my little handy calculator here just to make sure, so I'm not getting all crazy. Yeah, that's 64. And then half of that, we said 32. Okay. What's 8 times? Oh, I'm sorry. I'd said times 2 a while ago. That should be times 4, which is 32. Okay. And then times 4 again. Oops. 128. Now some of y'all are going to cheat and just put this straight into your calculator and y equals, and it'll give you these right here. So let's go to graphing these things. Okay, 0, 1 half, right there. 1, 2, right there. 2, 8, right there. Okay, 3, 32, way up there. That's all we're going to get. That's it. Number 8 is done. Okay. Okay. Oh, number 9. That's that regressive stuff again. This is a regression equation. It's telling us what? That this is where we start. So the 0 is 0.5. Okay. So this is our starting point. This is a sub 0 equals 0.5. Well, what do we say this is? This is previous term.